Hello everybody, welcome to cumulative number 17. We're going to start here with number 44, which is the conic section. So these problems ask us to first identify the conic. And so let's look at 44 and 45 at the same time, and let's take a look at these squared terms. If the squared terms have the same coefficient, same lead coefficient, they would be circles. Because neither of these have the same leading coefficient, we know already that these are both not circles. I also know that these are both not parabolas because in a parabola, either the x squared or the y squared is squared, not both. That means that these are either an ellipse or hyperbola. So if I looked at 44, I noticed that the squared terms have different lead coefficients, and there's a plus in the middle, which means that this must be an ellipse. These have different lead coefficients, but it has a subtraction in the middle, so this must be a hyperbola. And these are good gut instincts to have before you start completing the square, because you know what your shape should look like in the end. So if I look at number 44 and I start to complete the square, I would like to organize this in a little better way. Get all the x's together, get the y's together, 25y squared minus 150y, and you move the 144 to the other side. Now for each letter, each variable, you're going to take out a greatest common factor. So I'm going to take out a 9, be left with x squared plus 8x. Then we're going to complete the square so that we can get this into vertex form. GCF here is 25. Take a 25 out of 150. You are left with negative 6y. And that's going to equal negative 144. And then I'm going to add two numbers on this side as well. So whatever I do to one side, I have to do to the other. So the special number is always completing the square, b over 2 quantity squared, so that would be 16. But the number I'm adding over here is really 9 times 16, which is positive 144. And then b over 2 squared here is 9, but what I'm really adding over here is 225. So if I simplify, we'd have 9 times x plus 4 quantity squared plus 25 times y minus 3 quantity squared equals these three numbers added up. These cancel, so you just have 225 over here. Now I know, because this is an ellipse, that ellipses must be equal to 1. So what we'd have to do is divide everything by 225, so we can get this equal to 1 over here. And if I do so and I reduce, 9 divided by 225, or 225 divided by 9 is 25. This becomes x plus 4 quantity squared over 25, plus this fraction here reduces to 1 over 9. You're left with y minus 3 in the numerator. So this would be the equation of my ellipse in standard form. And I like it because I know it's an ellipse because I have double squared terms. I have a plus in the middle, and it's equal to 1. So now I have this one in standard form, and so now I'd like to find the key features of this ellipse. So the first thing I'm going to do is, before I do any graphing, is say, what is the center? Center is always x comma y. The signs flip, so my center is negative 4 comma 3. Other information I need to know are the a, b, and c terms. The a always has to do with the major axis or the type of ellipse I have, horizontal or vertical. So let's take a look. An ellipse, to determine what type of an ellipse it is, you always look at the largest denominator, and so because the largest denominator is underneath the x value, I know that this is a horizontal ellipse, which means that the a, or the major axis, must be horizontal. And to find the a term from here, you take the square root of the denominator, because this is really a squared, so a must be 5. That also means that the minor axis of the ellipse must be the square root of the minor axis, so that would be 3. And to find c, we use the Pythagorean Theorem relationship. Because we have a plus here, the Pythagorean Theorem relationship is a squared minus b squared. So we'd have c squared equals 5 squared 25 minus b squared 9. So c squared equals 16. Take the square root. So c is a nice answer of 4. And what these mean again, a represents the distance from the center to the side on your major axis. So now if I do some plotting, I know my center is at negative 4, 3. And I know because a is 5, and a represents my major axis, and my major axis is horizontal, that I'm going to go 5 units in each direction from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The minor axis B means from the center I go up and down 3 units. The minor axis is vertical because I said that this was a horizontal ellipse. So 1, 2, 3, 1, 2, 3. So we already have the basic picture of our ellipse here because we already have the vertices, major and minor. Okay. What also we could find is the foci, but just to be 100% clear, my major vertices are going to be on the horizontal axis. Those 2 points ended up being at 1, 3 and negative 9, 3. My minor vertices were on my minor axis, which was vertical, and those 2 points are going to be right here at negative 4, 0, and up here at negative 4, 6. So just to be 100% clear, this is what we did in class, just again, helping you out. The other things we found in class were the foci, and the foci are always on your major axis, in this case horizontal, and everything depends on the center here. And C represents the distance from the center to the foci. So if I'm starting at my center and I'm moving left and right, that means that the x-coordinate of my center is changing. So I would do negative 4 plus the distance of 4, 3. 3 doesn't change because we're not going vertically. Then negative 4 minus 4, 3. Let me get rid of this little symbol here. So that means that my 2 foci are actually at 0, 3 and negative 8, 3, which, if graphed, makes sense because 0, 3 is right here, and negative 8, 3 is right here, and the foci in an ellipse are always inside the entire shape, so this completely makes sense. So now the ellipse is graphed correctly, we have the correct standard form, and we found a lot of the key information we needed to graph it. Number 45, we said this was a hyperbola, and the process is the same. To complete the square, we would rearrange everything. 9x squared plus 36x minus y squared minus 6y equals negative 18. And then we take out greatest common factors. We have x squared plus 4x plus blank. Take out a GCF of negative 1. Y squared plus 6y, plus blank equals negative 18 plus blank plus blank. So my special number here is going to be 4, b over 2 squared, but I'm really adding a 36 over here because of this distribution. This is a 6, so b over 2 squared is 9, but I'm really adding a negative 9 over here. So when this is moved over, we had a negative 18 over here, just to be a little bit more clear with my handwriting here. So we have a negative 18. So if we combine on this side, negative 18 plus 36 is 18, minus 9 equals 9. Over on this side, we have 9 times x plus 2 quantity squared, minus 1 times y plus 3 quantity squared. And because I know that a hyperbola is also equal to 1, I know I need to divide everything by 9, so I can get that to happen. The 9's here cross out, so you're left with x plus 2 quantity squared. You could technically write over 1 if you'd like, minus y plus 3 quantity squared over 9 equals 1. So I like the way this looks as well. I know this is in standard form because the positive term is first, there's a subtraction in the middle, and it's equal to 1, which leads me to believe it is a hyperbola. So let's talk about some key information that we need from this shape as well. The first thing that's very important is, again, thinking about what the center is. The center is going to be negative 2, 3 because of the x, y. We also need to find the a, b, and c terms. So this time, if you are dealing with a hyperbola, in an ellipse, the biggest number determines what type it is, but in a hyperbola, it's whatever is the positive term. So in this case, it also happens to be x. So the positive term determines what type of hyperbola it is. So again, this shape is horizontally based. And if it's horizontally based, that leads to the a term. So the a term this time is the square root of 1 or 1. The minor axis is the square root of 9 or 3. So if I'd like to find my c value, I would use the Pythagorean Theorem relationship again. But first pen is really freaking out here. So if I'd like to use the Pythagorean relationship, we have c squared equals, in the equation we have a minus, so it's a squared plus b squared. So c squared equals a squared, which is 1, plus b squared, which is 9. So c squared equals 10. So c must be the square root of 10. So in terms of key information for hyperbola, we will get to more of that in just a little bit, but let's see what we have so far. If I graph the point -2 up 3, this is my center point. For a hyperbola, the shape, again, does not look like an ellipse. It actually looks like an ellipse cut in half and flipped. So we have to draw a rectangle this time because our shape depends on that more. And so if this is a horizontally based hyperbola, we are going to go 1 unit left and right, because that's what a is. And then we're also going to go 3 units up and down. So that means that this would be my little rectangle. And then a little rectangle helps determine where I'm going to draw my picture. Because this is a horizontally based hyperbola, we need to draw our picture left and right. And so these are the vertices, left and right. So we would draw our shape like this, and we would draw a shape like this. So in terms of identification, we have that the vertices would be these 2 points, because these 2 points, the graph doesn't exist there. So it would be here and here. So that would be at -1, 3. And the other one would be at -5, 3. We also can find our foci. So this time, again, because the hyperbola is horizontal, we are moving from the center and we're going in both directions to the left and to the right. So if everything depends on the center, what is changing is the -2. So one of the foci would be -2 plus root 10, 3, and the other foci would be -2 minus root 10, 3. So if plotted, these points would be just past the vertices inside your shape. For both an ellipse and a hyperbola, your foci are always within your shape. Number 46, find an equation. So this is a parabola, and it's a parabola that's facing upwards, and so it's what we expect. So this would be x minus something squared equals 4p, whatever p is, and then y minus something squared. And the reason the x is squared is because every parabola we're used to is x squared, and this looks like a normal one. And so first let's focus on what the center is, or what the vertex is. So the vertex is 2, -2. And so we have x minus 2 equals 4p, y minus -2. So we have x minus 2 quantity squared equals 4p times y plus 2. Now this equation's almost done, except we need to figure out what p is. And p is defined as the focal length, which really means you're going from your vertex to your focus. And if you look at your picture, we have your vertex right here. This is my focus point, and it is 1, 2, 3 units apart, which means that my p is really 3. So my final equation would be x minus 2 quantity squared equals 12 times y plus 2. I like that this 12 is positive because the parabola is facing upwards. That makes sense. So that's a good thing. Now, how would you know if the y was squared instead? If your parabola was either facing this way or this way, it would be y squared instead of x squared. If your parabola is either facing up or facing down, that's when it's x squared in some way, shape, or form. So guys, the next video, we will start with number 47. Thank you.